video lecture, we're going to talk about recursion in Python. Okay. I am really sorry for the background noise. Okay. So recursion in Python. This is what we're going to talk about. Okay. So first of all, what is recursion? Usually when you deal with this topic, you're dealing with recursion or recursive function. So it plays out in the form of a function, and as you know that when we are using a function, we call the function to actually execute it, and one function can also call another function. Okay, so in case of recursion, one function calls itself. Okay, the rule of thumb is a function can call another function, but in this case, when you are dealing with recursive functions or recursion in Python, a function can call itself. Okay, that's number one. Then in these type of functions, another feature of these functions is that the user will loop through the data. What it means is whatever data there is in the function body, user will loop through it, or the function will loop through this data, and I'll explain how. Another thing that you need to remember is, since there is looping and since the function is calling itself over and over, there are chances that function will execute for not a definite time. So it could be that function may never terminate. Okay. Right? There are chances. So you have to focus on this aspect as well, how you can avoid it, because if it never terminates, you'll never be able to see the output. Okay, remember that. So remember, this function calls itself, it will loop through the data, and then you always have to remember certain mechanism to stop the function. Okay, because if it is looping through the data, it may never terminate, it never stop. So you have to always remember certain mechanism to terminate the function. Okay, this is very important. Usually we take example of what is that? Factorial function. Okay, so we'll take that only to help you understand this concept better. Okay, you have to remember this. This is related to this one. And so let's take an example of factorial function. Okay, now what is factorial? How do you find factorial of a number? Factorial, so for example, if you have to find factorial of 4, this is the symbol for factorial. So if you have to find factorial of 4, it will be 4, 3 multiply 2 and 1. Okay, if you have to find factorial of, let's say, 5, it will be 5, 4, 3 to 1. So this is how you find the factorial of a function. And also factorial of 1's factorial, obviously it will be 1, right? And 0's factorial is always 1. Okay, so 1's factorial and 0's factorial is always 1. Okay, so how can you find factorial of a function using recursion? Okay, this will help you. This example will help you understand the importance of recursion in Python, and also how you can create a function in Python, recursive function in Python, and how it actually executes, right? How you can actually decide to put conditions that will terminate it and all of that. So yeah. Okay, so let's start. How do we create a function in Python? First of all, we use def, definition, and then you need to give a name to the function. So let it be fn, and then this is the variable that will be passed by the user. So in this case, suppose it is 5. Okay, or that will be too long. So suppose this is 3 or 4. This is 4, right? So now you want to create the function. What can be the possible halt or stop point for this function? I told you that with 0 factorial it is 1, and with 1 factorial it is 1. So if I'm trying to find factorial of, let's say, 5 or let's say 4, it will go all the way till 1, and then it doesn't have to keep continuing with the function, right? So this can be taken as the halt, stopping point, right? Similarly, if the value of a is 1 or if the value of a is 0, it doesn't have to go all the way till 1. It doesn't have to perform any calculations. It can just say, yeah, it is 1, that's it, and stop, right? So this gives you these 2 points. This gives you, and that is why it is very important that you understand the logic first, how this program actually, how the logic works, how the algorithm works. So these 2 points give you the halt point, the stopping point, and this will make sure that your function will terminate. It will not loop through the data infinitely. Okay, so what we'll do, we will first create this condition only, that if a is 0 or if a is 1, what can we do? We can return 1. That is it. Okay, but if it's not that, that means a is not 0, a is not 1, it is something else, then what should happen? It's 5, 4, 3, 2, and 1. What is it? What is this ultimately? 5, that is the number. Then we have 5 minus 1, right? 4. Then we have 5 minus 2, 3. Then we have 5 minus 3, 2. Then we have 5 minus 4. You see, right? So it's like you have to keep decreasing 1, okay? And finally, lastly, when we have 5 minus 5, this is going to be 0, right? Even this, it will stop here only, because 5 minus 4 will be 1, and then I'll explain how this is going to happen. So this is the whole funda here, right? So what we'll do is, if a is something else, right, what we can do is we will return a, that is suppose 5 here, and then we have 5 minus 1. So this will be a minus 1. But if you look at this statement closely, you'll realize that if I see this whole thing, 5, 4, 3, 2, 1, this definitely looks like 5's factorial. Okay, but if I look at this thing, 4, 3, 2, 1, this looks like 4's factorial. But then if I look at this statement, 3, 2, 1, it looks like 3's factorial. Then this one looks like 2's factorial, and so on. Right? So ultimately, in 1 factorial, we are finding factorials of other numbers as well. So here, instead of writing a minus 1 because a is, let's say, 5, but then ultimately we are finding factorial of 4, right? That will be 5 minus 1. So that is a minus 1. So this is like we are calling the function again, a minus 1. Okay, we are calling this function again. Let me write it somewhere here maybe. Okay, now see how it plays out. So suppose value of a is 4. Okay, that means we will call fn of 4. So we call this function. Okay, we are calling this function. Now what is a's value? If a is 0 or 1, it will return 1, otherwise it's gonna return this statement. So a is 4, so it will return a multiplied by fn a minus 1. So what will be returned? A is 4 multiplied by fn, 4 minus 1 is 3. Right? Now when it returns this, what is happening is actually we are again calling the function. We are again calling this function with a different number. Okay, so this time the function will be called with a's value as 3. So 3, again it is not 0, it is not 1. What is it going to return? It's again gonna return 4 star. So this time 3. So it will be 3 multiplied by a minus 1. So 3 minus 1, it will be 2. Okay, and next time what will be returned? 4 and 3 will be like this, and function of 2. So it will be 2 multiplied by function of 1. Now when it is 1, when this is 1, when this function is called, it goes here, a's value is either a or 1, 0 or 1. So it's gonna return 1. So we will have 1 here. So the output will be return 4 into 3 into 2 into 1. Okay, and 24 will be the result. Okay, this is how recursion or recursive functions work. And let me give you an example here, practical example. So we'll create a function first. Okay, again def a. We'll put two conditions: if a equals to 0, or if a equals to 1. This will actually make it little bit, okay, let me this will make the function look longer, but so def f and a. Yes, if a equals to 0 or a equals to 1, so in this case we'll return 1. Okay, else what we're gonna do is so we will take a as 4 so that it will not take much time, right? I mean, otherwise once you have created the function, it doesn't matter if you are taking a big number or a small number, but when you are when you're creating the logic, it is always better to take the smallest, not the smallest, but the small number that you can work well with. So what we are going to return a, and function a minus 1. Okay, now let's call this function with 4. Okay, all right. I don't know why I'm making these mistakes. Always forgetting. All right. So function a, if a equals to 0 or a equals to 1, return 1, else return a multiplication a minus 1. Okay, so let me check a star function a minus 1. So we are calling the function over and over again. So okay, it gives you 24. So I've already explained the logic how you got this 24, and you have to keep in mind these 3 things. This function will call itself, it will loop through data. You can see how it is looping through data. I mean, you have this function, it is looping through this data over and over. It's going to check it over and over, and that actually makes sense because it is going to call itself. So it's going to use its definition over and over, but you have to make sure that there is a statement that will help this function terminate on time. Not on time, or like yeah, with time. It shouldn't go to like, there shouldn't be an infinite loop. Okay, so this is recursion in Python, and if you have any doubt, feel free to ask. I'll see you in the next video lecture. Till then, take care.